Welcome Pre-Cal students to class today on this Thursday the 20th. Hope you guys are doing well. Hope you're ready to learn some math today and finish up this last lesson before we start reviewing for your test on this coming Monday, which leads me to my first announcements. Matthew and Caleb, here we go. There will be a test on Monday. There will be a test on Monday, so if you're not going to come to my house, I'd like to know that no later than Sunday, please. No later than Sunday. Remember how we're doing the review sheet? At the end of this lesson today, I will give you the review sheet, okay? You are to work on this as much or as little as you prefer. I recommend working on it a lot. There are 44 problems. However, I'm not going to do a video anymore because you guys have not been watching them, which have been watching those videos, which is fine. You know that, but when you come in Monday, we'll work for a good 2 hours, and then whatever problems we don't get to, as soon as you guys leave, I'll make that video for the rest of those problems, okay? Your integrity sheets are due on that Monday, so when you come to class, you cannot watch any more videos for credit or homework. So please be men of integrity and be honest with that. And then everything is made up. So congratulations to you guys. I have everybody's tests in, everybody's quizzes in. And so we should be totally caught up there. So good job to you guys. Grab your notebooks, please, your pens, pencils, calculators, and books, and let's get started with today's lesson. I hope the word problems went well for you, by the way. Be sure to study those word problems from lesson 1.3. They will be on the test. And you need to watch the video and study those really well until you're very familiar with those word problems. We're going to be looking today at a certain form of linear equations, and this form is called the slope-intercept form. The slope-intercept form. And let me pause and say this. Even though we're doing pre-calculus, a lot of this material now in Chapter 1 is reviewing of Algebra 2. Let me say this. Even though we're covering topics from Algebra 2, you realize we cover almost 3 or 4 days material in one class period. The material I'm going to cover today, I would usually cover in 3 or 4 days in Algebra 2. So yes, it's review, but we're going very quickly. I give you one example, sometimes two at the most, of one problem or one type of problem, and then we move on. So this should look familiar, and if it doesn't, relax. I'm still going to teach you how to do this. Now understand, there are many forms of linear equations. Many. There's the point-point form, point-slope form, slope-intercept form, double-intercept form, standard form. We are just looking today at one type. And the type, again, we're looking at is called the slope-intercept form. So your heading today is slope-intercept form. The lesson number is 1.4, and the date today is the 20th. And I would encourage you to write that down. Slope-intercept form, lesson 1.4, February 20th, 2014. And I'm going to go pretty fast, so feel free to pause the video when you need to. Okay, let's start off by looking at the slope-intercept model. The slope-intercept model, okay? Y equals mx plus b. Y equals mx plus b. Please write that in your notes. Y equals mx plus b. Now, notice some characteristics of this model. And these three characteristics that I'm going to give you are really, really important. So please make note of these characteristics. Number one, notice the variable y is completely isolated on the left side of the equation. That means there's nothing over here on the left side of the equation except a y. Notice there's no number in front of it, like a 2 or a negative 2 or an 8 or any number at all. It's just y. Now if you want to get technical, yes, there's a 1 in front of the y. But other than 1, there's no coefficient in front of the y. The y is all by itself. We call that completely isolated. Notice number 2 on the right side of the equal sign, the first term, and I have the first them. That should be term right there. And I'm going to go ahead and fix that right now real quick. Notice the first term. If I can get this to work here, the first term is the x term. All right. So please make note of that. On the right side, right here, of the equal sign, the very first term is your x term right here. Now m is going to be a number. M is a number. And so we call mx your x term. Notice characteristic number 3, one last thing, the constant term comes last. B is a number, and notice that comes last. So when you're asked to write a linear equation, let me get a quick drink here. In slope-intercept form, you want to make sure the y is all by itself on the left side, then your equal sign, then your x term, and then your constant term. Okay? Very important that you understand that. Now, the reason these characteristics are important is because when you are asked today in class to write a linear equation in slope-intercept form, you will need to remember these three traits. Okay? Very, very important. This next comment is very important also. Notice I've underlined it, I've bolded, I put it in bold print for you and italics, okay? So I would encourage you to write this down. This is so important. Whenever a linear equation is written in slope-intercept form, you know immediately what the slope is and what the y-intercept is. Let me read that again. Whenever a linear equation is written in slope-intercept form, you know immediately what the slope is, and you know immediately what the y-intercept is. Let me demonstrate for you. Let me show you what I mean. Okay, let me show you what I mean. Would you copy this example in your notes? Please write this down. Y equals 3x minus 6. Now you would agree with me, would you not? This is written in slope-intercept form, right? Y is all by itself, then the x term, then the constant term. Well, now listen to me. Whenever a linear equation is written like this, the number or the coefficient with the x is always your slope. So now, without doing any work at all, you know right away the slope of this line is 3. And don't forget, in math we use the letter m for slope. So m equals 3. And do you see this number here, this constant term at the end, -6? That number at the end is always your y-intercept. So without doing any work at all, you could simply look at this equation and you knew two things right away. You knew what the slope was, and you knew what the y-intercept was. Now, you only knew that because the linear equation was written in what form? Slope-intercept form. So, if the linear equation would have been written like this, that's not slope-intercept form. And so you would not know a whole lot about the graph. Now, if you got y by itself, that's a different story. So one more quick example. You can write this down or just watch. It's up to you. If I have y equals -2/3 x plus 5, notice it's written in slope-intercept form. The y is all by itself, then the equal sign, then your x term, then the constant term. You know right away the slope of this line is -2/3 because that's the number with the x, and you know right away that the y-intercept equals +5 because of this constant term right here. So that's what I mean when I say you know immediately what the slope of the line is and the y-intercept. Okay? Let's continue on. Let's take the equation below, okay, students, and let's write it in slope-intercept form. After we've done that, then state what the slope and the y-intercept are. So let's go ahead and let's write this equation in slope-intercept form. Now think about it. The model looks like this. So we know we want to get the y term right here all by itself on the left side. So here's what I'm going to suggest that we do. I'm going to take the 3x and bring it over, and when I bring it over it becomes a -3x, and now it's gone. And I'm going to take this -7 and bring it over and make it a +7, and when I do that it's gone. Now don't forget your negative sign here in front of the 6. So I'm left with -6y equals -3x plus 7. Wasn't that easy? I mean, that's a piece of cake. I'm going to erase these red marks. Look what we did here. See if I can get it right this time. Alright, look what I did. I brought the +3x over and made it negative. I brought the -7 over and made it positive. Now, is it quite yet written in slope-intercept form? Well, no. Look, y has to be all by itself, and I have a -6. So watch what I do. I divide this term by -6. I divide this term by -6, and I divide this term by -6. These will cancel, leave me with y. -3 over -6 is a +1/2. And a positive 7 over a negative 6 is a negative 7/6. There, we did it. We wrote an equation in slope-intercept form. Now let's find the slope and the y-intercept. Finding the slope and the y-intercept should be pretty simple because look, y is all by itself. So I know right away slope, which is m, equals 1/2 because that's the number next to the x. And then my y-intercept, by the way, most books will use b for y-intercept. That's why the model is y equals mx plus b. M stands for your slope and b is your y-intercept. So m is my slope, it's 1/2, and your y-intercept would be negative 7/6. If you want to put negative 1 and 1/6, I have no problem with that. Okay? Either one of those is acceptable. So there we go. Okay, so that's not too bad. Let's try one more real quick, just one more. You can try this on your own or you can work with me. Let's try one more of these. So I'm going to get y by itself. So the first thing I do is I leave my negative 3y here. I already have a 12. I'm going to bring the 2x over and make it a negative 2x. So now I have negative 2x. I want my x term to come first on this side over here. And then positive 12. Now notice my 12 was positive and it stayed positive. I did not bring my 12 over from the other side. My 12 was already over here on the right side. So I just kept it on the right side so it stays positive 12. Now my 2 became negative because I moved it from the left side over to the right side of the equal sign. Now let's divide everything by negative 3. And let's see what our final slope-intercept form is. Your negative 3's cancel. A negative 2 over a negative 3 is a positive 2/3 x. And a positive over a negative is negative. And 12 over 3 is 4. So there, I wrote the linear equation in slope-intercept form. Good job. Not too bad, guys. Okay? Now, I want you to list out the slope and the y-intercept. Well, the slope would be 2/3 because that's the coefficient of the x, and your y-intercept would be negative 4 because that's your constant term. So there we go. We're moving right along. These are not too difficult. Let me get a quick drink of water here and we'll continue on. Now let's try writing linear equations. This next comment is very important. Notice I've bolded it, underlined it, and put it in italics. Whenever you want to write a linear equation, always find two things: the slope and the y-intercept. The slope and the y-intercept. Hey, doesn't that make sense? Think about it. If I said a line has a slope of negative 2 and a y-intercept of negative 6, could you not write the linear equation in 1 second? Think about the model. Remember the model? Y equals mx plus b. I mean, I could write a linear equation right now. Y equals, my slope is negative 2, so I put a negative 2 in front of the x, and my y-intercept is negative 6, so I put a negative 6 for b. There we go. So do you see what I'm saying here? As soon as you know what the slope is, and as soon as you know what the y-intercept is, you can write your linear equation so quickly. Now we're going backwards, okay? In the past, I gave you an equation, you graphed it or you did different things with it. Now, I'm giving you information. Let me get a drink here real quick. And you're writing the linear equation. Do you see what I mean? So if you can find these two things right here, you can very easily write your linear equation. So let's practice some of these. Okay, let's put this into practice. Write the linear equation of the graphed line below. Now I'm asking you to write a linear equation. So right away you know you need to find two things. You need to find the slope and you need to find the y-intercept. Now the y-intercept is really easy. Remember, this is your y-axis and this is your x-axis. The y-intercept is simply where the line crosses the y-axis at. And unless my vision is failing, it looks like the line crosses the y-axis right here. Well, where's that at on the y-axis? 1, 2, 3. Positive 3. So just like that, I found the y-intercept. Okay? Now we got to find the slope. Now remember, when you go to find the slope and you have a graphed line, remember what the formula is? We learned this the other day. It's rise over run, plus or minus. Well, first of all, the line is sloping downward from left to right, so I know my slope is negative. Next, I've got to find 2 points that are what I call whole number points right here. That's a good point to use. So, I'm going to draw my triangle over and then down. Now let's find the rise. Remember, where you put your pencil, you don't count. You don't start counting until your first movement. So 1, 2, 3, 4. So I rose 4 units. Now let's rise. Let's find our run. Okay. So I put my pen here and I count on my first movement. 1, 2, 3, 4, 5. So I have a run of 5. So I just found my slope. My slope is negative 4/5. So I have a question for you. If I want to write the linear equation of this line right here, do I have my y-intercept? Yes. Do I have my slope? Yes. Then you're ready to write the answer. Here's your answer. Y equals, and then you put your slope in, negative 4/5. Then you put an x, and then you put your y-intercept, which is positive 3. So if you were to graph this linear equation right here, you would get this line right here. Okay, so I used to give you the equations and you graph the lines. Now I'm giving you the graph and you're writing the equation. So pretty cool. Okay, let's move on to the next page. I'm going to get a drink here real quick. Okay, let's write a linear equation that has these characteristics. It has this slope and this y-intercept. Well, whenever you're writing a linear equation, what 2 things do you need? Well, the slope and the y-intercept. That's what I said right back here. Whenever you want to write a linear equation, always find 2 things, the slope and the y-intercept. Well, I gave you both of them. So this is one of the easiest problems you'll ever do in this class. I've given you the slope. I've given you the y-intercept. So you simply plug in or substitute in those numbers. There we go. Your slope goes right in front of the x, and your y-intercept goes at the end as your constant term. You did it. You're done. Piece of cake, that easy. All right, let's write a linear equation with these characteristics. I've given you the slope, and I've told you the line passes through this point. So whenever I ask you to write a linear equation, you need 2 things. You need the slope, and you need the y-intercept. Now, I already have the slope, do I not? The slope is negative 2/3. So I'm good there. Now I've got to find b, my y-intercept. We've never done a problem like this. Remember the model that I gave you, y equals mx plus b? Did you know you can use that to find b or solve for b? You can use this to solve for b. Let me show you. Negative 3 is a x value, 6 is a y value, and negative 2/3 is your m value. So what are you going to put in for y right here? 6. What are you going to put in for m? Negative 2/3. What are you going to put in for x? Negative 3. And then plus b. So now we can solve for b, and we'll know what b is. So in the past, I've taught you guys, you simplify both sides of the equation. You cannot simplify 6, but on the right side, you can simplify these 2 numbers here. You can multiply them together. So a negative times a negative is a positive, and 2/3 times 3 is 2. So we have a positive 2 plus b. Now bring this 2 over and make it a negative 2, and we're left with 4 equals b. 4 equals b. So now I know what b is, just like that. Isn't that cool? So I know what the slope is. I know what the y-intercept is. So now you can write your answer. Here's your answer. Y equals, and then you put your slope, then you put the variable x, and then you put your y-intercept. And you've done it. You just wrote a linear equation that has a slope of negative 2/3 and passes through this point right here, negative 3, 6. Okay, let's continue on and try another problem. All right, what about this? Write a linear equation with these characteristics. The line passes through this point, and the line passes through this point. Okay, we don't panic, we just use the steps that Mr. Arrett has taught you. First of all, we're writing a linear equation. So what two things do you need to find? Well, you need to find the slope and you need to find the y-intercept. Now, there's a formula we use for finding slope. Do you remember what it is? It's y minus y over x minus x. You should remember that. So this is my x, this is my y, this is my x, this is my y. So y minus y, here's my first y, 3 minus a negative 4. 3 minus a negative 4 over x minus x, 2 minus 1. 2 minus 1. So it looks like my slope will be 3 minus a negative 4 is 7, 2 minus 1 is 1, 7 over 1 is 7. So there, I found the slope, 7. Pretty simple. Now let's find b. And I taught you, you can use this formula here to solve for b. Now, I'm going to show you something really cool and really interesting, okay? Watch this carefully. You say, well, Mr. Earhart, I'm going to solve for b, but I don't know which point to use. Well, I would like to show you that you could use either one of these points that'll work. I'm going to use this point in this equation, and I'm going to use this point in this equation, and you're going to see I get the same answer out for b. It doesn't matter. So let's first of all use this ordered pair. This is my x, this is my y, this is my m right here. So here we go. So for y I substitute 3, for m I substitute 7, for x I substitute 2, and then plus b. Alright, let's simplify the right side. 7 times 2 is 14 plus b. And now bring the b over and make it a negative 14, and we get negative 11 equals b. So there I solve for b, I got negative 11. Now, let's use the other ordered pair, and let's see if I'm right. Let's see if we get out the same answer. All right, here we go. So for my y, I'm going to put negative 4. For my slope, I'm going to put 7. For my x, I'm going to put 1, and then plus b. All right, let's simplify the right side. 7 times 1 is 7. Plus b. Now we bring the positive 7 over and we make it a negative 7, and that gives us negative 11 equals b. Look at that. So no matter which ordered pair I used, I get negative 11 for b. So we're not quite done yet. We're almost done. The problem said write a linear equation. Do I know my slope? Yes. Do I know my y-intercept? Yes. So write the linear equation. There's your linear equation. Y equals 7x minus 11. So to wrap this up, this part of the video here, we have some more to go over still, but to wrap this up, just remember this. Anytime I ask you to write a linear equation, you need the slope and the y-intercept. If you have those two things, you are totally home free. All right? Now, let's finally do one more thing, and we're just about, I think the very next page is the review sheet. Yep, so we're just about done. Finally, let's graph this linear equation using the slope-intercept method. Now, we've never done that this year, okay? You've learned it in Algebra 2, but we've never done it this year, so here we go. First of all, before I graph this line, would you please listen to me carefully, students? We are now going to learn 3 ways to graph a line. The one method is called the table of values method. We learned that earlier in a couple videos ago. We also learned the double intercept method. We learned that a couple of days ago. And now today we're going to learn to graph a line using the slope SI, the slope intercept method. Now, very quickly, I just want to review method 1. You don't have to take notes on this, just watch, okay? The table of value methods. Remember how we do that? Very quickly, we put a number in for x, we'll put in 0, 1, 2, and we'll get out a y. So put a 0 in for x, you will get out a 4. Put a 1 in for 2, negative 2, that would be 10. I think you get 3 and 1/3, I believe. And then put a 2 in, that's 4, that's 8. You would get 2 and 2/3. So let's plot those 3 points. 0, 4 is 1 point. 1, 3 and 1/3 is another. And then 2, 2 1/3 is another. Okay, so I'm going to very quickly graph that line. and that's good enough. There we go. Okay, so I just graphed the line using the table of values method. Now let's use the double intercept method. Remember how to do that? Where the x is, you put a 0. And where the y is, you put a 0. Now, if we solve this equation for y, we will get y equals 4. And if we solve this equation for x, we will get x equals 6. Okay, guys, I'm back, and I apologize, Matthew, Caleb. You guys know that. Hopefully by now you know I know my math pretty well, but mathematicians make little mistakes sometimes. I was looking here, and the y-intercept is 4, and then the x-intercept is 6, and I'm supposed to get the same line. I'm not going to get the same line. I'm going to get something like this. And so I did see what my mistake is, and I apologize. When I plot, and you probably caught it when I was teaching, you're probably like, wow, he's going to have to fix that later, and you're right, I will have to fix it later. But when I plotted those points, let's get rid of this line real quick here if I can. When I plotted those points, I put them in the wrong place. Remember, look in your notes if you wrote down, my table of values was 0, 4, and then it was 1, 3 1/3, which is all the way up here, and then it was 2, and then 2 2/3, which is here. So that's where the 3 points should have been, right there. And so let's bring this over here. Put it right here. And then we'll see if we can't make this fit. And that's just about perfect right there. All right, very good. So there we go. All right, sorry about that. So my table of values was 0, 4, 1, 3 1/3, 2, 2, 2 2/3, and I plotted my points incorrectly. That's my fault. Now back to the double intercept method. My y-intercept is 4, and my x-intercept is 6. 1, 2, 3, 4, 5, 6. It's off just a hair, but if I were to graph that line, it would look something just like this. And it's close to the same line. I know it's not perfect, but I mean, I'm not drawing my 3 1/3 perfect either, and my other fractions, but it is very close, very similar to the other line. Now, we've learned those two methods in the past. Let's end with our new method. I want to teach you today, you should remember this from Algebra 2, I want to teach you today how to graph a linear equation using the slope-intercept method. So let's try to slide this out of the way over here, and here we go. All right, we're going to graph this linear equation using the slope-intercept method. The first thing you do is you get y by itself. So if I want to get y by itself, bring this 2x over and make it a negative 2x. So I have 3y equals negative 2x plus 12. Now we're going to divide each term by 3. If you divide 3y by 3, you're left with y. If you divide negative 2 by 3, you're left with negative 2/3. And if you divide 12 by 3, you're left with 4. So here we go. Using this method here, I know that my slope is negative 2/3, and I know my y-intercept is 4. So let's pretend this line is not here. Okay? If we can get rid of this line, let's pretend this line is not here. And let's erase these ordered pairs. Okay, now that I've erased those, let's see if I can't take this information here and graph the line. First of all, I know that I have a y-intercept of 4. So 1, 2, 3, 4. I put a point right here. Now I know the slope is 2/3, and I know the top number is my what? We should know. My rise, and my bottom number is my run. So from this point, I'm going to rise 2. So 1, 2. I started here, 1, 2, and then I'm going to run 3. Now the question is, rise always means go up. So I always tell my students, always go up. Don't go down. I don't care if there's a negative sign here. Don't go down. Rise means to go up. So you're here at 4. Rise means go up, and your rise number is 2. Your top number is 2. So you go up 1, 2. And then your run number is 3. But notice your slope is negative. So because your slope is negative, you would not run to the right, you would run to the left. If your slope would have been positive like this, then you would run to the right, a positive direction. But because your slope is negative, we're going to run to the left 3. So I rose 2, 1, 2. Now I'm going to run 3. 1, 2, 3. So there's my triangle. Look, here's my triangle, up and over. So if I want to graph the line, all that I have to do now is connect these 2 points here, and I've got my line there. It's so fast. All right, and if you want to erase your triangle, you can. You don't have to, but you just graphed a line using the slope intercept method. Now remember, this is old stuff for both of you guys. However, we're covering, so this is almost like a week's worth of material in Algebra 2. So we're going fast. I expect you to know this stuff from the past. We're kind of reviewing it, and I need you to practice the homework to make sure you're understanding this, okay? All right, here's your review sheet. Now, I told you it's 44 problems long, so the ball is now in your court. I am not going to do a review sheet video for you. You're welcome to work a bunch of these or none of these or some of these. It's up to you. That is I would recommend you try to do half of it before class, but that's up to you, okay? But what I do want to point out to you is on Monday when you come to class, we'll work on the problems, and then whatever we don't get to, I will make a video for you for the rest of those problems, okay? I hope you guys have a good day. If you have any questions, call or email.